Okay, removable discontinuities. Occasionally, a graph will contain a hole, a single point where the graph is not defined, indicated by an open circle. We call such a hole a removable discontinuity. For example, the function f of x, which is equal to x squared minus 1 divided by x squared minus 2x minus 3, may be rewritten by factoring the numerator and the denominator. So when we factor the numerator, the difference of squares, we end up with x plus 1 times x minus 1. In the denominator, we factor x squared minus 2x minus 3 to be x plus 1 times x minus 3. So what do you notice? Well, you can notice that we have a common factor in the numerator, which is x plus 1, and a common factor in the denominator, which is x plus 1. So notice that x plus 1 being a common factor to the numerator and denominator, the zero of this factor is x equals negative 1. So if we take x plus 1 and set that equal to 0, we have x is equal to negative 1. And that is going to be the location of the removable discontinuity. And notice also that x equals negative 3 is not a factor in both the numerator and denominator, so the zero of this factor, x equals 3, is the vertical asymptote. So you can see that in the figure. So negative 1 is the value of x, and then whatever the output is where the hole is located on the graph. So if we want to find out what that output is, we know that negative 1 is the x value. And if we plug in negative 1 into the remaining function of x minus 1 over x minus 3, we would have negative 1 minus 1 over negative 1 minus 3, which is negative 2 over negative 4, which is a positive 1/2. So the output is going to be positive 1/2. And if we look at that on the graph, that's where this point is located.